We're looking at question 3, and it refers to our reference table. It says our reference table lists out the waves which belong to the electromagnetic spectrum. So let's check out that list. Let's click on it. Let's go to it. Okay, perfect. So let's talk a little bit about what's going on in this table. Everything to the right, so let's look at it. Wavelength is written on the top. Everything on the right-hand side has really large wavelengths. And you could tell 10 to the negative 1. As you go to the right, this is just 1. This is 10, 100, 1,000, 10,000. So everything towards the right, as you've moved further to the right, has longer wavelengths. So longer wavelengths. So your radio waves, long radio waves, and just radio waves has the longest wavelength. They're really wide waves, super wide. The distance between crest and crest for a long radio wave is 10 to the fourth. That's 10,000 meters long. That's super long. That's the wavelength for this type of wave. As you go to the left, the wavelength decreases. These waves get tinier and tinier and tinier and tinier and tinier and tinier and tinier. They continue to get really, really small as you move to the left. So let's talk about our frequencies. Now that's how quickly they oscillate. If we're looking at the right side of the table, we're talking about waves that oscillate very slowly. 10 to the fifth, so 100,000 waves per second. That sounds like a lot, but it's really slow for a wave, really slow oscillations. So over here, these waves would be everything that would be considered low energy because they're not shaking very fast. They're not oscillating very fast. They have low energy waves. So these waves will be less damaging. That's why we use them in general life. Like our radio waves is what we use for Wi-Fi's. Radio waves, yeah, mostly just Wi-Fi stuff, and then your radio or your TV signals, um, and then microwaves. You might be using them for your actual microwave, or you could be using them for your cell phone reception. Um, and then you have your infrared. So these are all considered lower energy because they don't oscillate as quickly. Now, once you get to the other side of this divide, now we're talking about higher energy waves. And we know they're higher energy because they oscillate much faster. Their frequency is much greater, 10 to the 15th hertz, 10 to the 16th hertz, 10 to the 17th hertz. These things are oscillating or moving extremely fast. They're oscillating ridiculously fast. So they carry a lot of energy with them.